My name is Steve Ocepek. I work for Trustway Spider Labs division, and put together this presentation about long-term sessions, calling it "This is why we can't have nice things." So we're going to take a look at what long-term sessions are, what do I mean by that, how I kind of came up with that idea, and there's actually a tool I'm releasing at Black Hat that you can use to detect some of these long-term sessions, understand what's going on in your network, who's doing what, that kind of thing, and actually start to make some decisions, behavioral decisions around what's out there. So basically, myself, where I got into this, right, was I started a company in 2001. It's called WholePoint, and what we did, we were one of the first NAC companies. What happened was I hooked up my laptop and put the network card in it. It was a wireless card. It was back in the days like the old Avaya gold cards. I don't know if anybody remembers those things I got in the mail. And I plugged it in, and I was reading the book, and I was looking at the link light. The link light was on. And I was like, what does that mean? I was looking at the driver, maybe the driver initiated or something. No, the thing had actually joined a network, right? It actually got onto a network. So I thought, well, that's kind of weird. So I started pinging around. I got a public IP. I was looking at like database servers and stuff. I was like, what the heck's going on? I call my buddy. I'm like, hey, ping this address. He says, yeah, it works. Okay. And I pulled the card out. I say, it still works. He says, no. I'm like, well, that's kind of messed up, man. And so I thought, well, that's a business plan, right? I mean, there's going to be this big problem around rogue devices come into the network. So we made this NAC. This is kind of the early, before really Gartner called it NAC, right? We made a network access control device that actually used, believe it or not, arc poisoning to do some of this stuff on the wire. So it kind of got to be a packet head doing that. It did both pre and post admission NAC, which is kind of cool, doing behavioral things. And that's kind of where I'm coming from here. I did a lot of behavioral network analysis. And one of the things that I always wanted to chase was looking at these long-term sessions. And then just recently, Trustway bought Mirage. They bought me. And I got in, and I said, hey, Nick, he's the head of Spider Labs. I said, hey, I'm kind of a cool guy. I spell later with an 8. And I like, my hair's kind of messed up, and I'm like, I think I belong to you guys. And he's like, yeah, come on in. So it was kind of cool. It worked out. So what do you care about long-term sessions, right? What's the big deal? Well, here's a number of long-term sessions I don't think you want, right, generally speaking. Bind shells, okay? So somebody breaks in your system, they drop down a bind shell, it connects back to you, or you connect to it, you leave it open for a long period of time if you're the attacker. Those kind of things you obviously don't want in your environment if you're watching a network. These credit card sniffers that are coming out, leaving long-term connections out to somebody who's watching the credit card information. Remote control, some people have problems with like go to my PC, LogMeIn, things like that. That's obviously something you don't want. And of course, if you fire a kid that works above an arcade and he like comes back into your office like late at night and he gets zapped by a laser and he goes into cyberspace and he meets up with Bruce Boxleitner and they like take over your stuff, well, that's kind of like a bad thing too. So, I mean, that was like a 2-hour session. So I'm just saying. So the example is, okay, so, we got a smiley face guy and we got a couple users and they're doing HTTP. This is your general case for, web traffic. And I'm all like, hey guys, how about, quotation or 1 = 1. And, I'm like, exploits. And I jump in there and then I throw down a bind shell. And notice what happens over time. Time passes, bam, that thing's still alive while everyone else is gone, right? So the whole concept I'm trying to throw out is, you got all these connections are making, the web connections are basically very, very short term. If you look at a long-term TCP dump, you're going to see this stuff that's just kind of firing out there. It's kind of fire and forget. It goes out, it's transactional, it grabs the data, it shuts down, whereas these are connections that are alive for long periods of time. But we can't just say long-term sessions are bad, right? I mean, there are a lot of things that you might like that open up long-term sessions. One's instant messaging. That might be, you might not like that. You might, it's up to you. You should be able to make the decision whether you're going to allow that. Large file downloads, especially if you're like on a 28.8 modem or whatever. I mean, or you're downloading gigabytes of data, you're going to have a long-term session that's open, while that data is being downloaded. Streaming media might throw that off. Rich web apps. Comet is a technology that leaves some of these connections open for long periods of time. If you look at like Facebook chat, it's a good example. And I know how you kids like your multi-user dungeons and those kind of things. So that's obviously something that would stay open for a long time. But so that brings up the question. Okay, I got good stuff. I got bad stuff. How do I tell a difference between the two? Okay. So really, what we're seeing is everything's going towards web apps. I mean, generally speaking, 2008, there's a bunch of, obviously I have all the words here that HTTP web traffic's overtaken P2P, continues to grow. That's pretty damn big. I mean, overtaking P2P, it's HTTP is now 46% of all traffic. P2P is like at 37%. So what we're seeing, I mean, you see it, Web 2.0, right? We're replacing all our traditional apps with long-term apps. And so what that in turn means is that a lot of what we're looking at on the wire looks like this. Short term, you get your HTML, you get your bytecode, you get your images, and you get off. You open up the connection, you shut it down. So again, this is kind of like, HTTP 101. You basically open up a SYN, you send a SYN packet to do a request, a SYN ACK comes back if it accepts your connection, and then an ACK, and that's called the three-way handshake. And then we go up the stack a bit and we say, okay, I want to get some content. And then HTTP says, okay, and then you kind of do your thing, and it says fin at the end. That closes the connection. Okay, so again, very definite start, very definite stop. We're talking about literally maybe a minute at most in most of these things. So what makes it long-term, right? What are we going to do to say this is a long-term connection? We're going to say, we're going to start paying attention to the duration. We're going to start paying attention to the source, okay? So duration could be different for every scenario. Web servers, a long-term connection on a web server could be 5 minutes. File servers, maybe it's an hour, depending on the size of the files. It's all going to be situational. Maybe from anything inside my environment going out. Maybe if I have a local LAN and I'm talking internet servers, maybe I'm going to say something that's long-term is 10 minutes or more, something like that. That's going to help a lot with kind of the signal-to-noise ratio. The whole idea is to build up something that gives us contrast, something that lets us say, that's weird, right? That's an unusual, there's something very unusual going on here because this connection, unlike these other connections, has lasted a certain period of time. The other thing we have to figure out is who started the connection. That's kind of tough. It's kind of a challenge. One of the things that tool does, you'll see, is it actually will look at a session that's already been established and figure out who the server was based on some logic. And we'll talk about ways of doing that. Not so normal source is basically your web server, right? Your web server is generally offering content. It's not really initiating connections. So if somebody, obviously if something's going on making your web server initiate connections, you might have a problem there. So getting back to, how we're going to manage this stuff, we're talking about whitelists, and we need to define what does okay look like, what does good look like. This is a common way to do it for internal user PCs, where we're saying, you're allowed to do IM, you're allowed to do these types of long-term sessions, but anything else I want to know about. So things to call out, comment web apps, instant messaging. But the challenge there is how do we do that, right? You're talking about these things that are clusters. If you connect to AIM, you're not just going to say, well, I can just say that this IP, this one or two IPs, are the AIM servers. There's going to be like a whole cluster of those. So we need to figure out a good way to go about that. And I've got a concept here that works for that. So proof of concept is the name of the program that I'm releasing here is it's called ackack. And it got that name because not only does it detect new connections, it actually detects existing. So like I was saying, as a pen tester, going into an environment, a lot of times I want to see what's going on. I not only want to pay attention to connections that are being established now, but I want to pay attention to connections that have already been established. And especially if you're doing an audit and you want to see if somebody's been in that environment and they're maybe throwing credit card numbers out the door, you won't, that probably has already been established. You're going to want to see that connection that's already there. So what ackack does, it allows you to create policies using duration and source as a criteria, and it basically lets you group things together. And I think the most spiffy thing about it is that the program calls you commander, which I think is kind of cool. So basically, source detection. All right, who started it? We have to figure that out, especially if we're going to jump into the middle of these communication streams. The source I'm defining really is the initiator of the communication stream, the servers, who it's talking to. And so there's three basic ways that I came up with to do this. The first one's kind of generic. It's basically port guessing. Believe it or not, works pretty good in most situations. The idea is that you have a source port that's generally very high, and you have the server ports generally very low. So in most cases, when you look at this traffic, the source port's like some, really high, like 40,000, 30,000, 40,000 range number. And obviously, the target port's going to be 80, 443, 139, what have you. So Port guessing is just saying, hey, whichever one's lower. It's pretty darn good. It does get confused on P2P, but if you're building out a tool, it's good to use that as kind of a last resort if none of the other methods work. The port list is actually, I was looking at doing this, but it wasn't quite as cool as what I originally thought. You'd have a list, almost like Etsy services. You'd have a list of all these ports, and you'd say in precedence order, these are the things that trump anything else. But what I found is basically you're almost like using Etsy services. You're redoing it, and at that point, there's so many different services out there that it really didn't help that much. The idea I really like is source detection. And what that does is it looks at a session established. You see there at the bottom of the screen, this port 52909 and port 4444. So this is two higher ports, and I'm going to say, I'm just going to test this. Which one of you guys is going to give me a SYN-ACK? And so I send a SYN port to port 5209 on local. I send a SYN packet to port 4444 on remote, and hopefully one of those guys gets back to me. Now that could, again, we kind of need to have some logic where if this doesn't work out, if nobody responds, we need to have some default behavior. But this, in most cases, this works very well. It does add one packet though for every session guess, so that's the thing. So I was talking earlier about how we're going to apply this policy, and one of the main components of that is groups. We need to classify this stuff. We need to kind of group it together. We need to say AIM. We need to say these are the AIM servers. You're allowed to talk to AIM. I have to group that together. So what I've done in ackack, the best thing I figured out and where I'm at in my thinking right now with this is I used whois. And kind of the rationale is that whois is going to give you, if you give me an IP in a server cluster, like I say AIM, right? You give me an IP and I do a whois for it, it's going to come back with a net block. And that net block is going to represent the IP address space that is owned by that business unit inside the organization, okay? So there's kind of a question, I have a question and answer there, kind of back and forth. How do you do it? You use whois, but hey, AOL's an ISP. Did you just allow everybody in AOL to hack my stuff? And really, when I say the business unit, generally speaking, AOL has tons and tons of whois space. They have a lot of different networks. So generally speaking, and that's important to stress, generally speaking, net blocks support apps such as AIM, don't intermingle with the IPs given to users. That being said, you should always check that out because you are taking a pretty big swath of address space at that point and trusting it. So policies based on what we just talked about with groups. Now we're just going to apply some simple policies. This is kind of basic stuff. And we're just going to say what's interesting to me. So this is where I start to get in the format. What you're seeing on the screen there is it's basically the format that ackack takes. And you say, here's the source. And then it's YAML. If anyone's familiar with that. So it's like this is the server group, and this is the duration. So if somebody in source establishes a connection with this server for this amount of time, let me know about it. And if it's undefined, if you want to make a rule about anything you have not defined in your groups, use the capital X to define undefined. So a couple usage examples here. What the heck do you do with this thing? So I kind of see it being used as two different ways. As a countermeasure, somebody that's watching a network and trying to actually defend it from attack. Again, watching for abnormal sessions. I mean, if you get an alert in the middle of the day that some session it's connected back to some cable modem in some part of the world that you're not familiar with, then it's probably something you want to be looking at. And you can connect this thing to a monitor port. It's a sniffer, right? This is not, I should probably stress that early on. This is a sniffer. This isn't something that's sitting on a PC and just watching that single PC. This is something that's actually, it's going to watch network traffic itself and keep track of sessions for you. So you can hook this up to a monitor port, network tap, etc. One thing to note, this took me about a month to make. It's proof of concept code. If you want to send me performance numbers, that'd be great. It uses some C stuff. It uses an event loop called EV, which is actually really cool, but it's kind of slacker Perl. So just like say, your mileage may vary. It will show you packet drops. So you do get some level of performance numbers while you're watching this thing. So you use those groups and policies to report the interesting sessions. And then as you go through this process, the idea is you make changes to your policies and then you try it again. So here's a good example of kind of a generic one. servers, you want, maybe let's say we want to alert each time a session is established for more than 5 minutes with our web server. That's a good example. So again, we have a, let's say we're a company, we have a web server, it's offering general, HTML, it's offering images, and we want to know when one of those connections lasts longer than what we think is appropriate. Send us an alert every time the server initiates out, right? That's kind of weird stuff. Inside the network, we're going to have a different idea. We're going to say, let me know when one of my desktop PCs has something going for like more than 10 minutes. And I'm going to exclude with AIM. So it breaks down pretty easy. The groups, I'm going to define, here's my public IPs, and then the inside address there, address space. So this is what my group.yaml file looks like. Inside the network, I'm claiming, the 192.168 space. I'm claiming the servers using a range. It takes a variety of different formats. And notice below it says AIM, and then it has a couple different entries that are in parentheses. Those parentheses denote that I need to do a whois query on those, and those will turn into the net box. Okay, so basically what I did is I took a sampling of AIM servers, put parentheses around those, and it's gonna get that whole address space there. And here's our policy. It's, like I say, it's kind of simple stuff. Inside, if anything inside in our inside group talks to anything unknown for more than 10 minutes, send me an alert. Okay, and then a couple lines down, we're going to alert whenever anybody opens up a session with a server for more than 5 minutes. So I say unknown, talking to servers, 5 minutes. That's interesting. And then for the servers, obviously we got two things. If the servers talk to unknown or AIM, if we define that, any amount of time, 0. So I'm saying if they ever initiate a connection, send me an alert. So I also see this kind of in pen testing tool. It's a sniffer. So there have been a lot of situations where I've been doing a test and I want to figure out what is interesting to the people who are working in the environment. So I want to actually say, there are a number, they'll give me a target zone, like PCI zone or something like that, but there's always a certain amount of servers in there that people are going to talk to, maybe the developers are going to talk to usually, and leave SSH sessions open or what have you. So what you can do is, since it's a sniffer, you can start doing some ARP poisoning, throw ettercap in there, and jump in the middle of some of these sessions. And then there's a option in the config called report all. If you set that to 1, this thing's going to start to report to you all the sessions that it's seeing, and not just the alerts. It has a column that tells you about the alerts, but it's going to show basically everything. And if there's time, I'll bring it up real quick. So again, look for connections being made to PCI zone. Look for connections being made to external resources. Anything that they leave open for, like, let's say more than 5 minutes is probably something worth looking at. And then using the groups method, you can actually start to peel back like what's what, right? So here's a good example of the groups. PCI zones, I'm going to enumerate inside of PCI, my local environment, I'm saying this is the subnet that I'm on, so I'm going to define that as local. And then you can throw labels in there just for visual cues. If anybody talks to a printer, I'll know that that connection will be labeled printers because of that label there, and the mail server, I denoted that as well. So just to help you keep track of things. And here's a good idea of like a pen tester policy. If anybody in local talks to anybody in PCI for 0, let me know. If anybody in local talks to anybody outside this network for 10 minutes, let me know. If PCI talks to me, that's really, really interesting. I want to know about that, right? So just a few notes here. Again, it's Perl, but there are what they call par binaries. And it's kind of interesting. There's Java jar. Well, somebody wrote like par for Perl. And the idea is you can wrap all this stuff up and make an executable. So there's actually executable Perl. It's just exe files inside of the distribution for this thing. It should work on most other platforms if it's not Win32, Linux, or Mac OS. If you can compile Perl modules, you can pretty much get this working. The most exotic thing is called EV, but there's source code for that available out on the internet. Again, if you use the binaries, you don't have to care about any of this. Don't overlap your groups yet. It's in hash order, so you never know which one you're going to get, basically. Probably something we're going to straighten out pretty soon, but also source guessing. Remember, we were talking about the different ways of enumerating who the source is. This thing's doing source guessing right now. So again, this is version 0.5. check back. It's all going to be on the Spire Labs website. There's going to be a few more revs of this thing at least. So that thing we were talking about where I'm going to actually port validation, where I'm going to be checking which port's open by actually validating it, that's going to come up in here pretty soon. And yeah, I work in my basement and there's like a refrigerator down there, so I can't be held responsible for the last bullet there. I have a little bit more time, right? We're doing pretty good, so we could always pull this up. I'd like to open it up for questions, but while we do that, I'd like to show you the thing real quick. What I was doing earlier was I was seeing if I get any TCP on the wireless, and I was thinking about doing header cap and doing smart poisoning, but I don't know, I just probably shouldn't be doing that right now. But basically what you see here, we did see a few TCP sessions on the wireless, so based on that, if we get lucky, and I'm on the free Wi-Fi by somebody, let me see here. So we might be able to actually see this thing in action. Notice what I'm doing. I have my let me just show you that real quick. I have my policy set up to say local. Local is my local network. Let me show you that first. Local is 192.168.0016, so I'm just saying anything that falls inside the private address space there. And then my policy says if anybody in local talks to anybody outside for more than 10 minutes, I want to know about it. And then the config is saying, the one that's interesting is report all. Report all is going to show us everything. So instead of just showing us alerts. Report all can get pretty big. You hook this up to a mirror port, you're definitely going to want to use just report the alerts because it's going to get pretty chatty. So if you don't specify interface, it'll come up and ask you for one. There's a pretty good README file with this thing. I go ahead and throw it on the wireless interface, and maybe we'll get something. Maybe we'll get lucky. We'll see what happens. Yeah, you're going to get those session reports about every minute or so. Any questions? Yes, in the back. It's a great question. The question was how to deal with caching services like Akamai. I've been thinking about that. Where I kind of ended up with it was that I would probably do a who is kind of a thing for that until we start doing more behavioral detection. I think there's probably a better solution than whitelisting here, but it's kind of the first step. It's looking at session origination, looking at duration is something we haven't really done yet. But for now, I guess the way I look at it is, if we're whitelisting caching servers, at least at that point, all you're saying is don't alert me when a long-term connection happens for that specific device. And it's not impossible. Like next year, there'll probably be a talk on like how I just hacked into Akamai. I took over all these servers or something. But it's at least better than where we're at now, where I'm just oblivious to all of it. So, but it's a great question. It is something we have to talk about. Yes. Oh, it's a good question. The question is this TCP only, right, or is it handle other protocols? This proof of concept thing is TCP only. You can do some guessing sometimes to do UDP sessions. We did it like at Mirage. And what's now TrustWave NAC. There's some code in there to do UDP session guessing, which is really all you can do. UDP is basically a connectionless protocol. But yeah, this is TCP only. They're something certainly to look at because obviously all the attacks are not just TCP based. Oh, there's a few things. So. Somebody's 86 is talking to 74, 125. So this is not what we would call a long-term session yet. But like I say, as a pen tester, that's just interesting to me. So I'm going to do my who is on that. Well, I can't. I turned off my stack because people were having some fun. So actually, this is the fun part about being a sniffer, is you can just say, I don't have an IP, so do whatever horrible things you want. But no, please don't. But the I don't want to be your proof of concept. But you can do this without an IP, right? So if anybody wants to do a who is on that IP address, that'd be interesting. But that's what we're seeing just flying through the air right now on one of the wireless cards. Any other questions? Okay, guys, appreciate it. Thanks a lot.